Hello students, I hope that you are good, well and fine. In today's session, we will be seeing homogeneous differential equations. So what are homogeneous differential equations? So consider following functions in x and y, okay, like f1 y square plus 2xy, f2 as 2x minus 3y, f3 as cos y by x, f4 as sin x plus cos x. If you replace x by lambda x and y by lambda y, okay, and substitute these value in the above functions, what you will get? Let's see. So from here you can take lambda square out, okay, in f1, or you can write f1 lambda x comma lambda y as lambda square times f1 x comma y. In f2, lambda x comma lambda y can be rewritten as lambda product f2 x comma y. f3 can be rewritten as lambda x comma lambda y is equals to lambda power 0 f3 x comma y. f4 can be rewritten as f4 lambda x lambda y can be rewritten as sin lambda x plus lambda y cos lambda y, and this cannot be, or you cannot write it as some power of lambda product with f of 4x comma y. Okay, so what we have observed in first three functions f1, f2, f3, that f of lambda x comma lambda y can be rewritten as lambda some power of lambda multiply f of x comma y, but f4 cannot. Okay, this leads to the following definition of homogeneous functions, that if a function fx comma y is said to be homogeneous of degree n if capital F lambda x comma lambda y is equals to lambda of n f of xy for any non-zero constant lambda. If you can write your function in this form, then your function must be homogeneous function of degree n. Okay, and also we are taking this lambda to be non-zero. Clear? Okay, I hope it is clear. So as you can see in f1, this is homogeneous equation of degree 2, of degree 1, of degree 0. Clear? Okay, now some more. So f of 1, we defined it as x comma y is equals to x square multiply with y square divided by x square plus 2y divided by x. Okay, this means x square h1 multiply h1 y by x. What do we mean by that? This h1 is just nothing but your what? Function in terms of y by x. Okay, clear? I hope it is clear to you. Now f of 1 xy y square plus 1 plus 2x by y is equals to y square h2 x by y. You can also rewrite it as. Okay, I hope it is clear. Okay, now what is happening is that, okay, what we are trying to observe, okay, so similarly f2 f2 f3 f4 and f4. Okay, now therefore a function is a homogeneous function of degree n if f of x comma y is equals to x power n g y divided by x or y power n h x by y. Clear? A function f is a homogeneous function of degree n if this happens. Clear? There is another form. Okay, so now a differential equation of the form dy by dx is equals to capital F x comma y is said to be homogeneous if fx comma y is a homogeneous function of degree 0. Of degree what? Degree 0. Clear? This means lambda power must be 0. This means dy by dx, which is equals to capital F of x comma y, you can write it as equals to g of some function y by x. Okay, I hope it is clear. Now we make substitution. What substitution? That y, put y is equals to v times x. This means y is equals to v times x. This means derivative of this will be what? Dy by dx is equals to v plus x dv by dx. Using product rule. Okay. Now what you have to do is substitute this dy by dx, okay, in equation 1. In this equation you will get what? You will get v plus x dv by dx is equals to gv. Okay, and this you can rewrite it as dv x times dv by dx is equals to gv minus v. This means dv divided by gv minus v is equals to dx by x. Now this is what form? This is variable separation form, and here you can easily solve your differential equation in terms of v and x. Okay, so just integrate both sides. You will get what? This will be, as you know, this will be just log mod x, okay, plus some constant, and according to this what you will get, accordingly you will get your left hand side. Okay, I hope it is clear to you. So after getting the general solution, replace your v by y by x. Okay, I hope it is clear to you. So note, if the homogeneous differential equation is in the form dx by dy, then your fx comma y is a homogeneous function of degree 0. Then we make substitution x y by is equals to v. This means x is equals to vv, v y. Okay, then we proceed further to the to find general solution as we discussed above. That's it. Okay, for example, x minus y multiply with dy by dx is equals to x plus 2y is a homogeneous, and solve it. Show that it is a homogeneous. Okay, so in order to show that it is a homogeneous, we have to write our this right hand side expression somewhat in form of function in terms of x divided by y, or just replace your x and y by lambda x and lambda y respectively. Okay, let's see. So substituting, you will get lambda common from numerator as well as from denominator. You can cancel your lambda, which means that a lambda power must be 0. This means it is your homogeneous differential equation. Okay, I hope it is clear. Okay, so capital Fx is a homogeneous function of degree 0. So the given differential equation is a homogeneous differential equation. Okay, homogeneous differential equation. Clear? Now the alternative approach will be this way, is to substitute x by lambda x and y by lambda y to show homogeneous differential equation. The alternate way, which is to show that this right hand side expression can be rewritten as a function in terms of x divided by y form. Okay, like this, that take x common from numerator and x common from denominator. You will get what? You will get 1 plus 2y by x divided by 1 minus y by x. And now this is your function, this is your expression in terms of y divided by x. Okay, clear? So also this form also gives you what? Homogeneous differential equation where degree is 0. Now you can substitute your y as vx. You can substitute your y as vx. Then dy by dx can be replaced by v plus x dv by dx. So you can replace this left hand side, you can replace this. Okay, you will get what? V plus x dv by dx is equals to 1 plus 2v divided by 1 minus v. Okay, now rearrange some terms, you will get this. Okay, taking LCM and simplifying things and cross multiplication, you will get after applying the variable separation thing, you will get v minus 1 divided by v square plus v plus 1 dv is equals to minus dx by x. You can integrate this without any facing any difficulty, but in order to integrate this you have to do some manipulation. Either you have to apply your what partial forms. Okay, it's depend. Let's see what we are going to do. So this is just what minus log mod x plus some constant, and this what we have done here, we have done, we have multiplied numerator and denominator with 2, as you can see. Okay, and what you will get in numerator, you will get 2v minus 2, and this minus 2 can be rewritten as 1 minus 3 form. Yes, as you can see, 1 minus 3. Okay, 1 minus 3. Now you can separate them, as you can see. Complete the square method, use the completing the square method. Okay, in order to get this integration directly. And for this you have to substitute this denominator equal to t. You can get your answer. You will get, for this part you will get half of log modulus v square plus v plus 1. Now for this you will get, after completing a square, you will get this form, and this is what? Tan inverse 1 by a tan inverse x by a form. Okay, so you will get your answer as, in terms of v, as this. Now replace your v by y by x. Replacing v by y by x, you will get your final answer. Let me just show you. Okay, and do the respective steps. You will get your final answer as this: log of modulus x square plus xy plus y square. Modulus is equals to 2 root 3 tan inverse x plus 2y divided by root 3x plus some constant. Okay, which is your general solution for the given differential equation. I hope it is clear. Okay, let us move to a next example. So show that the given differential equation is homogeneous and we have to solve it. So in order to show the, you have two ways. One is to substitute x by lambda x and y by lambda y and show that lambda will be cancelled, or it will be the lambda power will be 0. Or the another way is to show that you can write your right hand side expression as some function of y by x. Okay, whatever you choose it, you can choose. So take y, we are using what? Substitution method, or you can also do what? Take x common from the numerator as well as from the denominator, you will get y by x form. Okay, but we are trying to do by substitution. So lambda x lambda y, so wherever you have y, replace it by lambda y, and wherever you have x, replace it by lambda x. So you will get lambda common from numerator and denominator. This means lambda power 0 multiply with f of x comma y. This means your capital F is a homogeneous function of degree 0. This means the given differential equation is a homogeneous differential equation. Now in order to solve, substitute y is equals to vx. This means dy by dx is equals to v plus x dv by dx. Replace this where? Replace this into the first equation. You will get v plus x dv by dx is equals to v cos v plus 1 by cos v. Now rearrange some terms. Okay, after cross multiplication you will get what? Cos v dv is equals to dx by x. Clear? Now from here what you will get is integrate both sides. You will get, this will be sin v, this will be log mod x, plus some constant. So as you can see, sin v is equals to log mod x plus some constant. This means applying the log property, you will get sin v is equals to log mod cx. Now replace v by y by x, you will get sin y by x is equals to log mod cx. This will be your general solution. Clear? Okay. Let us move to next example. So show that this differential equation is a homogeneous and find its particular solution given that x is 0, y is 1. Okay. So dy by dx will be this. Sorry, dx by dy will be this. Now take y common from numerator and denominator. You will get what? Taking y common numerator and denominator, you will have your form 2xyy e power x by y minus 1 divided by 2 e power x by y. This form. Now you can substitute x by y is equals to v. After substituting, okay, you will get what? So we substituted x is equals to v by y. After substituting, you will get this. Okay. Put dx by dy where? Put dx by dy in the equation 1. So differentiate this with respect to y. You will get dx by dy is equals to v plus dy multiplied dv by dy. Okay. So, okay. Now you will get, after substituting dx by dy in this form, you will get v plus y dv by dy is equals to 2v ev minus 1 divided by 2 ev. Okay. Now rearrange some terms, cross multiply. You will have 2 ev dv is equals to minus dy divided by y. Now integrate both sides, you will have this. This integration is just 2 ev. Integration for this will be minus log mod y plus some constant. Okay. Now replace your v by x by y. You will get your general answer as this general solution. But you need to find the particular solution, and in order to find particular solution, you are having special condition where x is 0, then y is 1. So put x 0, this will be just 2. Y 1 means 0. So C will be 2. So a particular solution will be 2 e power x y y plus log mod y is equals to 2. Okay. Now, next example. Show that the family of curves for which the slope of the tangent at any point x comma y on it, okay, on it is this thing. Okay, is given by this. Clear? I hope it is clear. Okay. Now, slope of a tangent at any point is dy by dx. Dy by dx. Now, dy by dx is given that x square plus y square divided by 2xy. As you can see, x square plus y square divided by 2xy. You can take x square common from numerator as well as from the denominator. You will have 1 plus y square divided by x square divided by 2y by x. You are having form y by x form. This means homogeneous differential equation of, okay. Now y is equals to vx. Substitute y is equals to vx. This means dy by dx can be replaced by v plus x dv by dx. Okay. Now substitute this dy by dx in here. Okay. You will get what? So you will have v plus x dv by dx 1 plus v square divided by 2v. Okay. Now rearrange some terms and use separation of variable. You will get 2v divided by v square minus 1 dv is equals to minus dx by x. Integrate both sides. You will get this. Okay. Now this integration is quite easy. Minus log mod x plus some constant which is we are taking as in terms of log. So log mod c1. This substitute your denominator as t. You can directly replace your numerator by just dt. So your integration for this will be just directly log modulus v square minus 1. Okay. Now using log property, you will have v square minus 1 multiply x is equals to plus minus c1. Now replace your v by y by x. You will have your final answer, general form in terms of x and y, and the final answer would be like x square minus y square is equals to constant multiply x. Okay, I hope it is clear. Okay, now 9.4, we will be solving 9.4. Okay, so we have to show that a given differential equation is homogeneous as well as solved. Okay, we have to solve them also. So quickly let's see. So first, on the left hand side we have to make dy by dx. On the right hand side we have to make some expression in terms of x and y. Now substitute lambda x in place of x, lambda y in place of y. So substituting, you will get lambda power 0 multiply fxy. So this is your homogeneous equation of degree 0. This means homogeneous differential equation. Now in order to solve, substitute y is equals to vx. After substituting y is equals to vx, this means dy by dx also can be also replaced by v plus x dv by dx form. This means you can make this form. Okay, now rearrange some terms and use the method of separation of variables. You will get what? 2 divided by 1 minus v minus 1 dv is equals to dx by x. Integrate both sides. What you will have? You will have 2 log mod 1 minus v minus 2 log modulus 1 minus v is equals to log x minus log k. Okay, using log property and rearranging some terms, you will get what? And also substituting v is equals to y by x, you will get y by x is equals to log k divided by x multiply 1 minus y square, y divided by x whole square. Okay, you will get your final general form as x minus y whole square is equals to kx e power minus y by x. Clear? Now second question, y prime is equals to x plus y divided by x. So dy by dx is already given. If you want to substitute, you substitute lambda x lambda y. You will have lambda 0 multiply f of xy, homogeneous equation. Now make your substitution. Y is equals to vx. This gives you dy by dx is equals to v plus x dv by dx. Replace them. Okay, you will get v plus x dv by dx is equals to x plus vx divided by x. X can be cancelled out. You will have 1 plus v, just 1 plus v. So rearrange some terms and apply separation of variable thing. You will have dv is equals to dx by x. This means v is equals to log mod x plus some constant. This means substitute v as y by x. You will get your final answer, your general form like this: y is equals to x log x plus cx. Now third problem. Third problem says x minus y dy minus x plus y dx is equals to 0. First of all, try to make dy by dx is equals to some expression. So dy by dx will be what? X plus y divided by x minus y. Okay, now what? Now substitute lambda x comma lambda y in place of x and y respectively. You will have lambda power 0 multiply f capital F times lambda power 0 times f of x comma y. This means homogeneous function. Okay, this means you can substitute. What substitution you have to make? Y is equals to vx. This gives you what? Dy by dx is equals to v plus x dv by dx. Replace dy by dx in here, and also what? Your substitute y is equals to vx. So after substituting these two things, you will get v plus x dv by dx is equals to x plus vx divided by x minus vx. X can be cancelled easily. You will have what? 1 plus v divided by 1 minus v. Rearrange some terms. Cross multiplication. You will get what? 1 by v square plus 1 minus v by 1 minus v square dv is equals to dx by x. Integrate both sides. This will be directly tan inverse v. This will, you have to substitute your denominator as 1 minus v square is equals to t. You will get what? The final answer for this will be half of log 1 plus v square. Okay. Now this will be just log. You will have this. So substitute again, replace your v by y by x, and the final answer will be like this. Okay. I hope it is clear. Okay. Let us move next. Fourth problem. X square minus y square dx plus 2xy dy is equals to 0. This means what? First of all, try to make left hand side as dy by dx and right hand side as some expression of x and y. So dy by dx will be minus of x square minus y square divided by 2xy. Substitute x as lambda x, y as lambda y. You will have lambda 0 product with fxy. This means homogeneous differential equation. Yes. Okay. Now substitute y is equals to vx. This gives you dy by dx is equals to v plus x dv by dx. Now you will have your differential equation in terms of v and x, which is v plus x dv by dx is equals to minus of x square minus vx whole square divided by 2x multiply with vx. You can see that x square will be removed. You will have only v square minus 1 divided by 2v. Rearrange some terms. Use the method of separation. You will have 2v divided by 1 plus v square dv is equals to minus dx by x. This will be minus log x plus some log c. And this will be substitute your 1 plus v square as t. You will have log 1 plus v square. Okay. So here we are using log property. You will get log c by x. So this means the final answer will be, in terms of v and x, will be 1 plus v square is equals to cx, c by x. Substitute v by y by x. You will get your final general solution in terms of x and y. X square plus y square is equals to cx. Clear? Okay. Let us move next. Now fifth problem. Again, we have to do the same thing, that try to make left hand side as dy by dx and right hand side as some expression in terms of x and y. So clear? So dy by dx will be x square minus 2y square plus xy divided by x square. This means fxy will be what? Fxy will be what? This means f lambda x lambda y will be what? As you can see, lambda power 0 multiply capital F of xy. This means homogeneous differential equation. Now substitute y is equals to vx. This means dy by dx is equals to v plus x dv by dx. After making these substitution, you will get your differential equation as v plus x dv by dx is equals to x square minus 2 vx whole square plus x vx divided by x square. This means in terms of v and x, you will have this as your equation after applying some rearrangements. Okay, and separation of variable, you will have half of dv divided by 1 by root 2 whole square minus v square is equals to dx by x. This will be just log x plus some constant. This is also some direct. We have already seen the direct integration for this form. This is of form what? Tx by a square minus x square. This is what? Just nothing but 1 by 2a log a plus x divided by a minus x thing. So we have just used the direct integration formula. Okay, and also substituted or replaced v by y by x, and you will get your answer in terms of x and y as this. So your general solution will be in this form. Clear? Okay, let us move next. Sixth problem. X dy minus y dx is equals to root x square y square dx. You will have dy by dx is equals to y plus root x square plus y square divided by x square. This means capital capital F of xy will be this. This means capital F of lambda x lambda y can be rewritten as lambda power 0 product with f of xy. This means homogeneous. Make substitution y is equals to vx and dy by dx is equals to v plus x dv by dx. After substitution, you will have this equation. This equation will generate what? After applying some manipulations, rearrangement of terms and variable separation, you will get this form. You know the direct integration form for left hand side as well as for the right hand side. This will be what? Left hand side will be log mod v plus root 1 plus v square is equals to log mod x plus log c. Now substitute back or replace your v by y by x. You will have your final answer as this. Y plus root x square plus y square is equals to cx square. Eighth problem. So eighth problem says x dx x dy by dx minus y plus x sin y by x is equals to 0. This means x dy by dx minus y plus x sin y by x is equals to 0. This means dy by dx will be y minus x sin y by x. So if you this gives you capital F, which will be this. Capital F of lambda x lambda y can be rewritten as lambda power 0 capital F of xy. Homogeneous equation. Substitute y is equals to vx. Okay, you will have dy by dx is equals to v plus x dv by dx. After making these substitution and a rearrangement of terms, you will have what? You will have cosec v dv is equals to minus dx by x, and you know the direct integration for both of the sides. Log cosec v minus cot v is equals to minus log x plus log c. Applying the log properties, you will have what? Cosec y by x minus cot y by x is equals to c by x. We also replace v by y by x. So your general solution will be in this form. Okay. Now ninth problem. Your dy by dx will be this. Capital F will be this. Capital F of lambda x comma lambda y will be or can be rewritten in this form: lambda power 0 multiply a capital F xy. This means differential homogeneous equation. Make substitution y is equals to vx. This gives you dy by dx is equals to v plus x dv by dx. Making these two substitutions, you will have this as your differential equation in terms of x and y. Rearranging of some terms and applying the variable separation thing, you will get what? You will have this as your expression. Now you can directly integrate both sides. Direct integration will be what? Quite easy. You have to substitute log v minus 1 as t, and this 1 by v dv can be substituted or replaced by dt. Just you know the direct integration for this, you know the direct integration for this, plus some constant in terms of log. You will have what? dv by v is equals to dt. I have already told you that this numerator, this 1 by v dv can be replaced by just dt. After substitution, you will have just log t. Log t means log of log y by x minus 1. We have already substituted or replaced v by y by x. So after applying your log properties and rearranging some terms, your general solution will be log y by x minus 1 is equals to cy. Okay. Now 10th problem. 10th problem will be, as you can see, this. So dx by dy is equals to this form. This means capital F will be this. So capital F lambda x lambda y can be rewritten as lambda power 0 multiply capital F xy. This means homogeneous. So make substitution x is equals to vy. This means dx by dy is equals to v plus y dv by dy. This means after substitution, you will have your expression in terms of your equation, differential equation in terms of v and y. After rearranging some terms and variable separation thing, you will have this form or this equation. Integrate both the sides. You will have log v plus ev is equals to minus log y plus log c is equals to log c by y. Substitute your v is equals to x by y. You will have this as your general form. So this is it for now. We will be back with the remaining problem of this exercise. So we have to stop here as time is running out. So thank you